Hello and welcome back to another small DILR series, and this time focusing on CAT 23. So we have a couple of agendas as usual. One is obviously looking for easy stuff to do. For most of you, doing all four problems is not going to be a realistic scenario. And solving one challenge or one problem set can take you beyond 90 percentile. Solving two challenges can take you beyond 99 percentile. So if you're a struggler and this DILR section is a challenge for you, then you're looking at solving two cases only. And if you manage that, not only you clear your cutoffs, you beat the competition by a good margin, right? So the main name of the game is set selection, the easy stuff that you want to do in the test, and that means spending 5 minutes, 6 minutes, or even more to select the right set to do. Because if you select the right set, your life is going to be very very easy. Our second agenda obviously is going to be solving this challenge and noticing what are the tools and what are the essential skills that I need to manage any such problem, right? So always keep an eye out for that. So let's dive into the problem. I think this was a fairly doable, manageable set. And as you read it, you will figure out that why it is easy, right? Because the story is easy to capture. You can understand it in one go. The first few logical steps are visible to you. In the difficult set, the language will be more complicated, the text will be longer and denser, the rules will be more complicated. The first few steps might not be visible to you. So that is one of my criteria for selecting an easy set. So let's dive into the problem. This was the very first problem set. So you could have been lucky with that you read it and you found it easy and you tried it and you worked it out, right? And a fun problem at that, and a good reminder of all the skills and all the approaches that we need to figure out any such problem. So faculty members in a management school can belong to one of the four departments: finance and accounting, marketing and strategy, operation and cons, behavior and human resources. So F, M, O and B, I will simplify my life, right? The numbers of faculty members in FNA, MNS, ONQ, BNS departments are 9, 7, 5 and 3 respectively. Great. No challenge so far in reading, right? Professor P, Professor Q, Professor R and Professor S are four members of the school's faculty who were candidates for the post of the dean of the school. So great, maybe an election is going to happen. Only one of the candidates was from O and Q. Okay, great. So O and Q has 5 people. One of them was a candidate. That means the remaining 4 were non-candidates, right? Every faculty member, including the 4 candidates, voted for the election. In each department, all the faculty members who were not candidates voted for the same candidate. Okay, great. Let me work with this example, right? And this is how I typically read and figure out on the spot. So you read this and you work out the story a little bit. So you say ONQ has 5 people, one of them was a candidate, so there will be 4 non-candidates. These guys vote together as a block. Whoever they give their votes to, they all go together to the same person. That is what this rule means. Now later I will also read that you cannot vote for the candidate from the same department. So it's not that they're getting together and giving it to the guy from their department, but whoever they give their vote to, they go together in one direction. So these 4 will vote together. But note, it does not say anything about the candidate. The candidate may vote along with them or may give his vote to someone else. So there is no information about the candidate. Because some people might make a mistake here, even I thought like that these 4 go together in one direction and this guy cannot go with them. But that is not given in the story. All it says is these 4 will go together. He may or may not vote with them, right? So that should be clear. Further, the rules for the elections are listed as below. There cannot be more than 2 candidates from a single department. So the upper limit for a candidate from any department is 2. I've already been told that ONQ has only 1 candidate, right? So what happens, let's say if FNA has 2 candidates from here, 1 candidate from here, and maybe 1 more candidate from some other story, it might be possible that one particular department has no candidates, right? So these are just things that I'm working out as I'm reading along. So there cannot be more than 2 candidates. A candidate cannot vote for himself, herself. Very common sense, easy piece of information to gather. Faculty members cannot vote for a candidate from their own department. So these guys, 4 and 1, 5 people cannot vote for the same department. They have to cross vote to somebody from some other department, right? Again, not a challenging piece of information. After the election, it was observed that Professor Pakrasi received 3 votes, Professor Qureshi received 14 votes, Ramaswamy 6 votes, Samuel 1 vote, and further information is given that Professor Pakrasi voted for Professor R, Professor Q voted for Professor S, Professor R voted for Professor Q, and Professor S voted for Professor P. Now, this might feel complicated, not the first half, the second half, but the moment you capture it on a piece of paper, your life will be very, very easy, right? So I've read the story. It's a common sense level story, nothing very challenging. It's not that I have to read it twice or thrice. Maybe a couple of rules, just pay extra attention to them, and then eventually just capture the data, right? And this is my data set now. FNA has 9 members, MNS has 7 members, ONQ has 5 members. One of them is the candidate, 4 are non-candidates, right? BNH has 3 members. Right now I don't know whether candidates are there or not for any of them. Furthermore, P has 3 votes, Q has 14 votes, R has 6 votes, S has 1 vote. Furthermore, I know that Professor P was given a vote by Professor Samuel, who is a candidate. That means he's got 2 non-candidate votes. So there is 2 non-candidate votes and 1 candidate vote. Same story I figured out for everybody else. Hit pause and figure it out for yourself, obviously. 14 total votes, that means 13 non-candidate votes and 1 vote from a professor who is Ramaswamy. Ramaswamy has got 6 votes, 5 non-candidate votes and 1 candidate vote. Samuel has only got 1 vote, which is from a fellow candidate from Professor Qureshi, right? Now, and I remember the rules of the story, I hope you do as well, or the sheet is in front of you or in a parallel tab so that you can look at it. So I know the game right now. And let's say I just start thinking of P. P has got 3 votes. Now, if I think of FNA, there could be 1 candidate and there could be 8 non-candidates. There could be 2 candidates, there could be 7 non-candidates. For similar, not more than that, I cannot go more than 2 candidates. Same story for MNS. There could be, and again, there could be 0 candidates and a total of 9 non-candidate votes, right? For the second story, same thing, there could be 0 candidates, 7 of them are non-candidates, could be 1 candidate and 6 non-candidates, 2 candidates and 5 non-candidates, right? This I already know. Here once again I could have just directly 3 candidates or 1 and 2 or maybe 2 and 1. But in any case, if I just look at this data, P has got 2 non-candidate votes. Now, if FNA voted for P, all 8 would vote together. Obviously, he hasn't even got 8 votes or 7 votes. So, I know these 2 people are not from FNA, right? Same logic, it could be 7 or 6 or 5. This guy hasn't got 7 or 6 or 5. Similarly here, you get 4 votes, but he hasn't got 4 votes. That means P, the vote that he is getting from must be from B and H, right? So these 2 votes are definitely from B and H. Now this one S, the Samuel, could also be from B and H. I do not know. That story I do not know. But this much I can say that B's story, he is getting his votes from B and H. And because he is getting 2 non-candidate votes, I also know my story is going to be this 1, 2, right? And why is that? Always stop and think for yourself. If there were no candidates, he would get 3 votes and he is getting 1 professor vote, right? So he would get a total of 4, but I have a total of 3 only. So this story is not going to work. Again, if he had 2 candidates, that means 2 different professors who are in the election, but he is only getting a vote of 1 of them. So out of these 2, he would get 1 and then the other one. The total would be 2. So that is not working. This has to be my story, right? 1 candidate from BNH and 2 non-candidates. Now, I hope you're getting the story. I hope you're getting the story, and the same game I'm going to play with over and over with all the numbers. And again, almost my set is done right now. Again, a big number, 14 and 13. Or look at R maybe, right? R has got 5 votes. He cannot be from BNH. BNH is obviously ruled out. He cannot be from ONQ because ONQ again will have 4 votes. So you will get 4 non-candidate votes because the total is 6. He's got 5 non-candidate and 1 from a candidate professor. This will not work. 8 and 7 will not work. That means this 5 is coming from Mark's MNS, and that means this has to be my story. That MNS has 2 candidates and it has 5 non-candidates. And this story is coming from these votes are coming from MNS, or just M also you can write, right? Once I figure that out, I've got 2 candidates here, 1 candidate here, 1 candidate here, total of 4 candidates. That means no candidates from here, and a total of 9 votes will vote together. Now this 9 and this 4 gives you 13. So great. Q is getting his votes from F and O and Q. And S is not getting votes from any departments. And pretty much my 80% of the story is already figured out. One question you can already answer from the story, right? So this is the major game, and because it would be visible, this story, you know, once you have figured out the language of the story, this data is very, very easy to figure out. It does not take even time to figure this out. You're like, okay, this has to be from here. Specifics you can get into later, but you know this guy is not getting votes from ONQ or Marks and Spencer, not Marks and Spencer, MNS or FNA, right? Then you play the game for a little while. You might take 2-3 minutes to figure this out, but you will come to this part of the story, right? So this is what we have got so far. Furthermore, what else can I say? P and S are not from the same department. Why? Because people cannot vote for the same department guy. If S has voted for P, they must be from different departments. Same logic over and over again. Q cannot be from the same department as R. R cannot be as the same department as P. And S cannot be as the same department as Q. So P cannot be with S, P cannot be with R. If people have to be together, P and Q can be together, right? So P and Q can be together, and R and S are from different departments. Or maybe R and S could be together, because R cannot be with P, R cannot be with Q, R can be with S, and P and Q are from the different department. Okay. Further think about it, all the information is there. I have to keep cross-checking the information. The moment I get into 2 different stories, the technique is trial and error. You assume one story to be true and see whether it works out or not. So can RS be together? Can RS be together? If they are together, I know 2 people are only from this one department, MNS, but R has got votes from MNS, right? That means R cannot be from MNS. That means R cannot be from the same department as anybody else, because there are only this department where there are 2 people, right? So this story will not work for me. P and Q are together. That means P and Q must be from MNS, and R and S are left. So it could be R from here, S from here, or vice versa, S from here, R from here. See if any rules are being broken. Hit pause, try it out for yourself, think for yourself, and you will see, no, everything is covered already, right? So that's it. My story is done. So it's a surprisingly easy set. The looking difficult part comes from the title of the test, CAT 23, and you obviously assume that it's going to be very difficult. But if you look at the number of steps taken or the kind of logic involved, all you have to do is understand the original story well, and it's a commonsensical day-to-day life kind of story, nothing very challenging there, right? So now we have figured out everything, and we can go towards the questions, right? I've captured all the data. FNA has 9 members, 9 candidates, 9 non-candidates, no one standing in the election at all. MNS has 7 total, 2 and 5 combo, 2 candidates, 5 non-candidates. P and Q are the candidates, and so on and so forth. R or S or S or R. If there is R here, S going to be here. If there is S here, R is going to be here, right? And this is the breakdown. And again, from the votes wise, for P, I've got 2 votes from B. For Q, I've got 9 votes from F and 4 from O and Q. For R, 5 votes from MNS and 1 from Professor Pakrasi, who is also from MNS. So 6 votes he is getting from. So all his votes are from MNS essentially. And S has got no votes from no department. And I can try out the questions now. Which 2 candidates can belong to the same department? I know P and Q can belong to the same department. Professor Pakrasi and Professor Qureshi. That's it. My job is done. And if I checked my rules earlier, the rules I wrote earlier, P cannot be equal to S, P cannot be equal to Q. From there, I also know this is and this is ruled out, right? Anyway, I know the story well now. The answer should not be a problem. This question could have been done earlier with just the first half of the table if you had not, even if you had not figured out PQRS story. Which of the following can be the number of votes that Professor Qureshi received from a single department? Professor Qureshi, 9 and 4. 9, 4 is not there. So my answer is going to be 9. So this question could have been done even earlier, even without working this part of the story. Why am I saying that? Because sometimes in a DILR case, you might not be able to solve everything, but you might be able to solve partially and get a question or two right. So always look at the question, they will give you a few hints as well. Even here, when I looked at the table and not the table, I mean just the story and then the questions said that if Professor S or whatever R is from BNH, right? So he gave me a condition which also told me that this part of the story will not be figured out by me by the data given, which helped me because I already knew that there could be two stories here, right? Which is often the case in such cases, such challenges. So this is my answer is 9 and again should be very easy. Wow, if Professor Samuel belongs to BNH, Professor Samuel belongs to BNH, that means this is the story and this is the story. That means R is from ONQ. Which of the following statements are true? Statement A, Professor Pakrasi belongs to MNS. Professor Pakrasi belongs to MNS, so was true anyway, right? Statement B, Professor Ramaswamy belongs to ONQ. Great, this is also true. So both statements A and B are true. That is my final answer, right? So once you figure out the table, the questions will not take any time. What best can be concluded about the candidate from O and Q? O and Q could be R or S. It was either Professor Pakrasi or Professor Qureshi, definitely not. It was Professor Samuel, cannot say. It was Professor Ramaswamy, cannot say. It was either Professor Ramaswamy or Professor Samuel. You can't see it on the screen, but it says Samuel. So my correct answer is going to be option D, right? So the effort is obviously in figuring out the data. The moment you have data in DILR questions, they hardly take any time, right? And the last question, which of the following statements are true? Statement A, non-candidates from MNS voted for Professor Qureshi. These 5 people did not go to Professor Qureshi. This is not true. Statement B, non-candidates from FNA voted for Professor Qureshi. This I already know. This I have checked many times. So this is definitely true. So which of the following statements? Only statement B is true, right? So not a challenge at all. So I hope you noticed what the game was. It was essentially just decoding the story, trying out, and it's essentially about saying, okay, if this is 3, it cannot be from here, cannot be from here, cannot be from here, it has to be from here. Now, this was the beginning easy step, right? You might have to read the story a couple of times. You might get confused and say, oh, 4 candidates, what is the non-candidate story? But considering that you can give it 10-15 minutes, there is enough time to play around with it, make a couple of mistakes, and then come to a final story, which does not require any calculation. It's commonsensical. The data is quite visible. If this is 14, I knew it had to be from FNA. All those other mechanisms in your brain will also work. You're just noticing the numbers, right? Once I figure out this table, then the second part might have been slightly challenging that, okay, P cannot be with S, right? And it might not be visible to you, but you play with it. You say, okay, P cannot be with R as well. Okay, great. So maybe P and Q are together, and the question is also giving you a hint that the story is not fully complete. So R and S you can't figure out, right? So maybe the second part was challenging, but the first part, figuring out this table, I think was fairly straightforward. Most people will be able to figure it out, and therefore I put it in the easy category because this will not take time. You can spend some time trying to figure this out and try out your logic. And once again, notice at the end of the day, it's about trial and error. That's a fundamental tool, right? You said R and S could be together. R and S could be together means they have to be from this department. But R got votes from this department. So small step after small step after small step. But often the starting point is when you don't know, when there is uncertainty, you assume a story to be true and you try it out, right? So trial and error, for the second part is definitely the name of the game here. So that's it for this challenge. I hope you found it easy, and I hope it also helps build confidence, at least after watching the solution, that okay, I might have struggled, my brain might have, because a lot of it is psychology, right? If you're convinced that the challenge is very difficult, you will overthink, overcomplicate the process. Here, it wasn't even about a complicated data structure, it was just about trying out the story and getting to the answer, right? So I hope this made sense. I will see you in the next video with the next challenge. If you struggled with the problem and you're watching the solution fully, then after a day, try out the problem by yourself and figure out each of the steps as if you had to explain to someone, right? That will further help you improve your logic game. So that would be my final tip. Even if you watch a solution, try it out by yourself and take it to a level where you can explain it to someone, because then you will have to articulate the logic over and over again. Because sometimes, like for example, when I'm solving, my brain is making noises. You're not saying it out loud, right? But when you say it out loud, it becomes even clearer. Your steps become even clearer to you. So that's it for this day. I will see you really soon in the next video.